Hello everyone. So in this video I will be talking about hyperparameters. So hyperparameters are settings that control how a machine learning model is trained. They are like knobs that you can turn to get the model to work the way you want it to. For example, imagine you are baking a cake and you have a recipe that tells you how much flour, sugar, eggs and other ingredients to use. But what if you want the cake to be sweeter or less sweet? In that case, you would adjust the amount of sugar. The same thing applies to machine learning models. The amount of sugar in the cake recipe is like a hyperparameter in machine learning model. Hyperparameters are different from the parameters that the model learns from the data. So these parameters are the features or the input that goes into training the model. And hyperparameters is something which are like the tuning that you do to the model. In this case, as we talked about, how do you want to train the model? So these are the hyperparameters. So if I have to explain more, the model learns the parameters from the data, while hyperparameters are set by the person training the model. The right settings for the hyperparameters can make a big difference in how well the model works. For example, if the hyperparameters are set too high, so in the example, like depending on how much sugar you add, so if it's too much, also it's not good. If it's too less, also it's not good. So it has to be the optimal amount. So sugar is something like a parameter, but how much is like a hyperparameter, like the quantity. So there's a lot of hyperparameters. So in this case, for example, if the hyperparameters are set too high, the model might just memorize the data it has been trained on and not be able to generalize to new data. On the other hand, if the hyperparameters are set too low, the model might not be complex enough to capture the patterns in the data. So finding the right hyperparameters for a machine learning model is important. This process is called hyperparameter tuning, and there are different methods for doing it. The goal is to find the hyperparameters that give the best performance on new data. So let's see the technical definition. This will be like brief. And in machine learning, a hyperparameter is a parameter that is set before the learning process begins and controls the learning process itself. Unlike the model parameters, which are learned from data, hyperparameters are specified by the practitioner and cannot be learned from data. Hyperparameters plays a crucial role in the success of a machine learning model, as they determine the model's capacity and its ability to generalize to new data. They are also used to control the trade-off between model complexity and its ability to fit the training data, known as the Bayes variance trade-off. So the importance of hyperparameters. The choice of hyperparameters can have a significant impact on the performance of a machine learning model. If the hyperparameters are set too high, the model may overfit the training data and perform poorly on the unseen data. On the other hand, if the hyperparameters are set too low, the model may underfit the training data and have limited predictive ability. Now let's see hyperparameters tuning. Hyperparameter tuning is the process of selecting the optimal set of hyperparameters for a machine learning model. There are several methods for hyperparameter tuning, including grid search, random search and Bayesian optimization. The choice of method depends on the size and structure of the hyperparameter space as well as the computational resources available. So we'll just see some common hyperparameters. So learning rate is very common across all the machine learning algorithms or the model. So learning rate, it controls the step size of the optimization algorithm during the training process. Regularization strength controls the amount of regularization applied to the model, which helps prevent overfitting. So this is talking about L1 and L2 regularization, also known as Rich and Lasso regularization. Number of hidden units specify the number of neurons in a hidden layer of a neural network. Number of trees specifies the number of trees in an ensemble model like random forest or gradient boosting. Depth of trees specifies the maximum depth of tree trees in an ensemble model. Minimum sample split specifies the minimum number of samples required to split a node in a tree. And second, this continuation, minimum samples leaf specifies the minimum number of samples required to be at a leaf node in a tree. Maximum features specifies the maximum number of features used in a tree-based model. Batch size specifies the number of samples used in each iteration of training in a neural network. Epochs specifies the number of iterations the model trains on the data. Initialization specifies the method used to initialize the weights of a neural network. Activation function specifies the activation function used in a neural network. So those were the common list of hyperparameters. Let's see on a per model basis. So this may come in exam, like you are working with some model and there is some issue. So which particular hyperparameters that you would like to investigate upon. So if in the case of linear and logistic regression, the hyperparameters are regularization strength, learning rate, number of iterations. For the decision trees, maximum depth, minimum sample split, minimum samples leaf, maximum features. For the random forest, number of trees, maximum depth, minimum sample split, minimum samples leaf, maximum features. For the gradient boosting, this is used both for regression as well as classification, and the previous model random forest is for classification, and this is also for classification. This is this is one for linear regression prediction and one for classification. And I was on gradient boosting. So number of trees, maximum depth, minimum sample split, minimum samples leaf, maximum features, and learning rate. For the support vector machines, which is for classification, kernel function, regularization strength, gamma, learning rate. And for the key nearest neighbors, this is both for classification as well as regression, number of neighbors, distance metric. And for neural networks, number of hidden units, learning rate, regularization strength, number of iterations, batch size, activation function, initialization method. For convolutional neural network, also known as CNN, this is used for image and image recognition, video and all. Number of filters, filter size, stride size, padding, pooling size, learning rate, regularization strength, number of iterations, batch size, activation function, initialization method. For the recurrent neural networks, it is for time series based data, speech, natural language, number of hidden units, learning rate, regularization strength, number of iterations, batch size, activation function, initialization method, and sequence length. And that's all. Thanks for watching.